Rate limiting protects your API endpoints from abuse. In this video, we'll use the rate and realip packages to build a simple IP-based rate limiter, all in just a couple of minutes. We're going to create a new middleware.go file, package main, and we'll create a function that has app as the receiver, rate limit, and this will take in the next HTTP handler, RPS, and burst. And then we'll return an HTTP handler. RPS is request per second, and burst is the maximum amount of requests that can be made at any given time. We'll talk more about these a bit later. In here, we'll have a clients variable, which will be a map of rate limiters. Here, the key will be the IP address, and each IP will have a dedicated rate limiter. Next up, we'll return a new HTTP handler using the HTTP handler func, pass it a function that receives the response writer and request pointer, and in here the first thing we'll do is get the IP address using the realip package. And now that we have the IP, we can check if it exists in our clients map. If it doesn't, we'll add it. We'll do clients IP equals rate new limiter, and this takes in a limit, which is our request per second, and burst. So by now we have a client's IP, which is a rate limiter, which means we can check if client's IP allows the request to go through. And if it doesn't, well, we'll respond with rate limit exceeded and return to stop the execution. Otherwise, we'll continue and call the next HTTP handler. And we still have a couple of problems, but we are conceptually done. I'll go to my routes file and apply the rate limiter to the entire router. I'll set RPS to 2 and burst to 10. We are using a token bucket type of limiter, and the way it works is we have a bucket of 10. This allows us to make up to 10 requests at once, and then each second that passes, another 2 requests are added to our bucket until we are back to 10 again. So the RPS is our replenishment rate, so to speak, how fast the bucket gets back to 10. In our case, since we are adding 2 requests per second, the bucket will be filled after exactly 5 seconds. I'll demonstrate. I'll open the terminal, run make w, which will start live reloading with air, and then open a new tab. And here I'll do a loop. I'll do for I in 1 through 11, and do curl localhost 8000/about. I'll do an echo to add a new line, and done. This will make 11 requests, and since our burst is 10, the last one will fail with a rate limit exceeded response. And if I rerun this quickly, only a couple requests go through because not enough time has passed for our capacity to be back to 10. Remember, only 2 requests are added per second, meaning that the bucket will be completely refilled only after 5 seconds have passed. So what we have now works, but we have some problems. The first problem is that maps are not concurrent safe. If multiple requests come in at the same time, Golang will panic because a map cannot be updated or read concurrently. The way we can get around this is with a mutex. We'll go here and do var mu, which will be a sync mutex, and we'll move clients here as well, and then in our handler, we'll call mu lock, and then defer a call to mu unlock. So once we enter this function, we lock everything inside it, and once we are done, we unlock it. This makes it so if 2 or more requests are processed at the same time, they will have to wait to obtain a lock. Don't worry, this happens really fast. The other problem is, right now our clients variable is an ever-growing map. Every time a new IP calls our server, it's added to the map, but that entry is never really removed. You can imagine after a while more and more entries are added, and we are left with a ginormous clients map eating all our server's memory. So we need a way to clean this map from time to time. What we'll do is we'll create a client struct that has a limiter and a last seen at time field. And now clients, instead of being a map of rate limiters, it will be a map of clients. Then each time we go through this middleware, we'll add a client instead of just a rate limiter, we'll update client's IP last seen at to time now, and adjust the if statement. And with this, we are now tracking the last time an IP made a request. This allows us to spin up a go routine that has a loop that runs every minute, goes through all the clients, and if the time since the IP was last seen is bigger than 5 minutes, we delete the IP from the map. Lastly, just as before, we need to make sure we lock the mutex before making any changes to the map, and then unlock afterwards. And we are now done. This Go routine will clean up our client's map every minute. Back to our routes file, we can set a global rate limit wrapping the entire mux, or we can be selective and rate limit a specific route. And that was it. If you enjoyed this video, don't forget to like it, share it, subscribe, click the bell button, all that good stuff. Bye!